Part one of the break assignment deals with potential difference versus work. Another term for work is electric energy or electrical energy. And we're going to draw an analogy to gravitational potential energy to kind of tie in electricity to some things that we already know. So if we're dealing with gravitational potential energy, if we look at a scenario of, for example, hiking up a mountain, and let's say that this mountain has some certain height of delta H. If here's me, very tiny, hiking up the mountain, and I have a certain mass of, I should do that in red also, I have a certain mass of m, and I am hiking with my gigantic friend who has a mass of big M. If we both hike up the mountain, so we both get to the top of the mountain, we've both gone through the same height, but since potential energy, Ug is mg change in height, for me at the top of the mountain, my potential energy will be little m times g times change in height. My friend's Ug will be bigger because my friend has a bigger mass, even though we still have the same acceleration due to gravity and the same change in height. So we would say that he has more Ug than I do because he has a bigger mass. But what's true about both of us is if we divided both sides of this by our mass, so if mine became Ug over little m equals g times change in height, divide both sides by mass for him as well, that says Ug over big M equals g times change in height. This quantity is the same for both of us. And what this quantity is that's a quantity that shows us the ability to have Ug at any specific point depending on what our mass is. Since we both went through the same change in height, and since there's the same acceleration due to gravity, we both have the same ability to have Ug. Dealing with electricity is fairly similar, that if you have, like near some random positively charged object, if you have a tiny positively charged object that has a charge of 1 coulomb, and then you have a more charged object that has a charge of, say, 5 coulombs, the more charged object will have a greater electrical energy because of its additional charge. But just like myself and my friend had the same ability to have energy because we were at the same position, we can say that both of these two charges have the same ability to have electrical energy, or the ability to have electrical energy, which the symbol for that is W. And that's what this term of electrical potential difference. What electrical potential difference is just the ability for there to be energy. Just like hiking up a mountain gives different massed objects the ability to have potential energy due to gravity, electrical potential, or an electrical potential difference between 2 points, gives charges the ability to have electrical energy. And the electrical potential difference is just the amount of energy that a charge has divided by how much charge it has. The equation for that is V, which stands for electrical potential. The equation for that is V, which stands for electrical potential, or potential difference, as it's often called. Potential difference is equal to W, which stands for electrical energy, divided by the charge of the object. The units for this, the units for potential difference, are the unit V for volt. The unit for electrical energy, since it's a type of energy, is joule. and the unit for charge is always the unit of coulombs. So what that means, if the amount of charge that you have is in elementary charges, you have to convert to coulombs in order to use this equation. And that just means that 1 volt is equal to a joule divided by a coulomb. In terms of how this ties into our study of electric circuits, what a battery does is a battery generates a potential difference by producing a separation of charge. In chemistry, you probably talked about different electrodes causing charge to separate, and this separation of charge occurs because chemical energy is being transformed into electrical energy within a battery. In our single cell battery over there, the acid that's dissolving the zinc electrode leaves behind 2 electrons, thus negatively charging it, and then there would be a potential difference. There's a separation of charge there, so charge could flow from the negative electrode to the positive electrode. What batteries do, a standard everyday dry cell battery that doesn't have sulfuric acid necessarily sitting in it, but a standard everyday dry cell battery works off the same principle as our wet battery, only it uses different substances to separate charge. But overall, what batteries do work on charge, causing them to separate. And in terms of an electric circuit, batteries are a source of potential difference. So batteries are what give a potential difference or provide a potential difference to an electric circuit, which, as we'll see when we start talking about circuits after break, allow electrons to flow around an electric circuit. There are some sample problems on here. The answers to these are actually provided. I'll probably type up my answer or write out my answers as well and post them on Schoology. But give this a shot, and then when you're good, check your answers with mine, and we can go on to the next video.